In today's tutorial, we will be considering the straight line. We will be considering the straight line. So I'll start by giving the definition of a straight line. So by definition, what is a line or what is a straight line? A straight line can be simply defined as the shortest distance, as the what? Shortest distance between 2 points. So when you have point A as well as point B, the shortest distance from here to here is what we can simply define as a what? Straight line. That's just the layman definition. And it has a constant slope. It has a what? Constant slope, and it extends infinitely on both sides. So it extends to this side infinitely and also to this side infinitely. However, we can just make a point to show the starting point of the line and show another point B which indicate the what? The end point of the what? Of the line. However, I have made mention of something in my definition, and that is what? Point. So I have 2 points here, point A and B. So I have to graph this line on XY plane so that we can get the full details on what line. So in order to show more light on the straight line, I am going to draw my Cartesian plane, the x-axis and the what? Y-axis, to show you how straight line can be derived on a what? On a plane. So on this axis, I have what? My y-axis. And on this axis, I'm going to have what? My x-axis. So where the y-axis and the x-axis intersect is called the origin. It's called the what? The origin. So let me quickly label the axis. I'll call this one 1, 2, 3, 4. Then on the y-axis, I'll call this one 1, 2, 3, 4, 5. Now, having drawn the xy coordinates, the xy plane rather, showing the x-axis and the what? Y-axis. So from the origin to the right, we have the positive x-axis, and from the origin to the top, we have the what? Positive y-axis. Also, I can continue to label from the origin down. I have the negative y-axis and I have the negative x-axis. So what am I going to do? I'm going to pick a point on the what? On the plane. All right. I can call that point what? Point A. Don't forget, we said that the shortest distance between 2 points, that is a line. So that means I need 2 points, all right? Now, what you are going to do next is you are going to trace this point to the what? To the x what? Axis. So you're going to get a value there, which is what? 2. However, I'm going to call it what? X. Now, I also trace it to the what? To the y-axis. I'm going to get another figure 2 there. I'll call it what? Y. Now, what do I mean? X and Y are called the coordinates of point A. And the coordinate always starts with the x-axis followed by the y-axis. This x-axis is also known as abscissa. X-axis is also known as what? The abscissa. While the y-coordinate is also known as the what? The ordinate. So sometimes in exam, you may not be told to use x-axis. You may say use the abscissa axis, and y-axis can also be known as what? The ordinate axis. So I haven't done that. So this is the first point. So I'll look for another point on the plane. So let me just pick another point here. I'll call this what? Point B. So I'll do the same thing. I'll trace it to the what? To the x-axis. I'll call that also x coordinate of point B. I'll also trace it to the what? To the y-axis. So let me just assume it is 5. And that's also what? Y-axis. So now we have 2 points A and B. So to differentiate the coordinates of A and B, I'll assume this one is x1, y1, and I'll assume this one is what? X2 and what? Y2. Is that taken? Okay. All right. So what do I need to do? I'll join the 2 points together in order to get my straight line. So I'll just take my ruler and I'll join this together. So this has given me a what? A straight line. So now, what are now the problems that you're going to solve here? the number one problem you may be asked to solve here is you should find the distance between between 2 points. So that's the first problem that we are going to look at how to attempt. So the first problem we are going to be looking at here is how to find the distance between what? The 2 points. That means you have to find the length of this straight line. And the first thing you're going to do is that you are going to form a right angle triangle from this diagram on the board. So via the straight line, I'm going to make a what? A right angle. All right. So having this, then that means this straight line will become my hypotenuse. So, and I can call this opposite depending on how I want to name it, and I call this what? Adjacent, or you can just call it the adjacent 1 and the adjacent 2. Do you know what I want to do here? I want to apply Pythagoras theorem. But before then, I'm going to find the distance, and I'll call this point C. I'll find the distance between here and here. Don't forget that my point A, I have x1, y1. Now, my point A here, the x coordinate is what? X1. And this point here, I want to find the distance between this point and this point here. So if you look at these coordinates here, I'm having what here? 5. And I'm having what here? 2. That means the distance between A and C is 5 minus 2. So what do I need to do? I'll just say, okay, that's what? X2 minus what? X1. So here becomes x2 minus what? Here, x1. And the distance between B and C, if you trace it here, so this becomes what? Y2 minus what? Y1. That is 5 minus 3. So here will become Y2 minus Y1. Okay, all right. So I'm going to apply Pythagoras theorem. So I apply Pythagoras theorem. We state that what? Hypotenuse square is equals to opposite square plus what? Adjacent square. So the hypotenuse square, the hypotenuse side is the what? Straight line that we are looking for, which is AB, line AB, all square is equals to. So our opposite will be what? X2 minus X1. I'm going to square it plus what? Adjacent. That's what? Y2 minus Y1 whole square. So what I did was I applied Pythagoras theorem. Of course, I'm going to square root both sides. So this will become what? Line AB is equals to the root of x2 minus x1 all square plus y2 minus y1 all square. And this gives us the formula for calculating the distance between 2 points.